Hello and welcome back. It's puzzle time with Sudoku Sleuth, and it looks like once again we're doing some mathematics. Now, I'm so sorry. It seems like suddenly all the constructors are just producing tons of puzzles are all about maths and multiplications and square roots. There's only so many sleuths I can possibly draw in a classroom setting doing math problems. But here is yet another one. We've got a young sleuth this time. You can see just the enthusiasm, the energy in those bright eyes. Already has decided that he's got to be a detective when he grows up, and he's got his signature detective hat on top, and enthusiastically doing some math problems, and tons of it on the you can see there on the blackboard behind him, and even more on the sheets of paper. I'm going to say it's not even a workbook, sheets of paper with tons of color to just continue doing tons of maths. So I hope you're going to forgive me if I'm going to feature yet another one, but I'm really looking forward to this one. It's got a 96% rating. And I think I can confidently say that's one of the highest rated puzzles we've ever featured on this channel. So I'm really looking forward to it. Let's take a look. We've got Multiplication Practice by RockyRoer, and the following set of rules. So normal Sudoku rules apply. So that means fill every row and column and every 3x3 box with the digits from 1 to 9 once each. Next we have cells with a grey circle, such as these, must be odd. Cells with a grey square, such as these, must be even. Now in each region, I'm going to interpret this as each 3x3 box. The 1, 2, or 3 digit number in the circled cells, so I'm guessing this is these pills, which could be sometimes 2 cells, sometimes 3 cells, or sometimes just the 1 cell, is the product of the cells in the circles, squares in that region. So essentially these 2 cells are a 2-digit number that you read from left to right, and it's the sum, not the sum, excuse me, it is the product of these 3 odd digits. Now, Rocky goes on to say, bonus points if you don't use a calculator. I'm going to give this a go, but I'll be honest with you, I may have to whip out a calculator looking at this. I mean, once you get to sort of 3-digit products, yeah, I'm not sure. I think I will probably need to use a calculator at some point. So, if you are not tired of mathematics, if you're looking at this puzzle and you're thinking, yep, I am equally excited, such as this young, bright-eyed sleuth that you saw earlier in the thumbnail, link will be in the description down below as usual to play along. And with that said, I'm going to restart the clock and see how I get on. So it's something that I'm going to do immediately, and I feel this puzzle is almost certainly about odds and evens, just because of the sheer number of them that we are given. And I'll do a few more than you may expect in here as odds and evens, and I'll explain why in a second. So, if you multiply 3 odd digits, I am absolutely certain they're not going to produce an even digit. So that's got to be odd. Try any combination of odd numbers. If you are multiplying odd digits together, you're going to get an odd digit. However, if any single one of these, actually this is another odd digit, if any single one of these has an even factor, you're going to get an even product. So take a look at box 5. Even though this is 2 odd digits multiplied by a single even digit, it's still going to be an even digit. That's even, even, even. All of these are even digits. And you can see already how this is helpful. Box 3, we've already got all the odd digits. We can complete box 3. Take a look at row 3 now. We've got all 5 odd digits. That's the remaining even digits. We've got 3 even digits in row 2. There is a fourth one. I was going to say there's a fourth one that could be in here or in there. But actually I've got 4 odd digits. I can only afford one more odd digit. So if the even digit is in here, then I need 2 more odd digits, and then I've broken the puzzle. So there's an odd even combo, 2 evens in here. These are odd. And there's an odd even combo in here. There's one more even somewhere in there with 2 odds. Can I keep this magic going? Yes, I can. Column 1, we've got 3, 4 even digits. We've got all of these have to be odd. Box 4, we've got 5 odd digits. All of these have to be even. Nearly. I mean, it's amazing. We didn't have to think about any mathematics, and we very nearly colored the entire grid. Now, I might be able to push it a bit more, but I'm not sure. If I'm honest, if there is, it's less obvious to me where it would be. I mean, I can see that one of these is odd, one of these is even, but I'm not sure how I can disambiguate these. Nothing stops this, for example, from all of these being odd. I know there is at most one more even digit between all of these. Actually, I know it's got to be in here because I've already placed 3 of them. So the fourth one has to be there. These have to be odd. Not huge revelations really at this point. Column 8, all of these have to be odd because we've already placed 4 even digits. I need a 4th in here. I got box 9, that's all odd. I need 2 more in here to get all of these. So these have got to be odd. Yeah, I've already got 1, 2, 3, 4. Yeah. So close. Can I do this? So I've got 1 more odd digit in here and then 2 evens. 1, 2, 3, 4, 1, 2, 3, 4, 1, 2, 3. Unfortunately, nothing helps me disambiguate here. Yeah. Okay. Time to do some maths. So, I think I'm looking at really the extreme boxes. So the extreme box in here, in my opinion, is box 2. We have a product that is only a single digit. I don't think there are many options to get to do this. So this cannot be a 1. If I have a 1, whatever digit I'm multiplying it with, I'll have to duplicate in the box. So it's a 3. Now, if I don't think it can be a 5, I think in general 5s are going to be very tricky, and I'll explain why when you think about it. But go on then. 5. If I put an even in here digits, I'm already at 10 or higher. And in fact, 5 times any even digit will always end up with a 0. As in, 10s, 20s, 30s, 50s, etc. Which obviously is not an available digit. And 5 times an odd digit will always end up with another 5 at the end, duplicating the 5. So 5 in general, I think, is basically a no-no on any of these. But anyway, where I was going with this is this has to be a 3. This is 2 or 4. 4 would already get us to 12. That would break. That's a 2. That's a 6. Let's have a think about box 3 now. I think it's actually quite tricky to get 3 even digits, 3 unique even digits to get to a 3-digit cell, 3-digit answer. So I think if I try and use a 2, even if I maximize the others, 8 and 6, it's 48 and 2, that's 96. So 2 doesn't work. So that means these are 4, 6, and 8. The 6 is in here. This is 4, 8. This is a 9. Sorry, a 2, excuse me. So 4 times 8 is 32 times 6. Probably the easy way around is to do 6 times 8 to get 48 times 4. It's 96 times 2, which is 192. No 3's in here. That's the 3. That's a 5, 7. That's a 1, 9 pair. 1, 9, very tricky to whatever we're meant to produce in here. If it's a 3, it's 27. Can't use 27 because we've got a 2 in row 1. So that's not 3. I said earlier 5s just don't work because 5 times 9 is 45. That would put a 5 in here duplicating the 5. This can only be a 7. This is 6. This is 3. This is not 2, 6. This is 4, 8. And lovely, this is another set of 4 8s. In here we must have a 2, 5 pair. In here to finish the row we must have 1 and 9. 4 8s gives me 2, 6 down here. So that's 12 times, can't be 1 because I'd end up with 1, 2 repeating the 2. Can't be 3. We already said can never be a 5 because 5 times 12 would be 60. 7 is actually a possibility. Is it? No. Is it? 7 times 12 would be 4, 8. Yeah, 70 plus. Yeah, 70 plus 14, so it's 84, that's correct. And then 9, I'm pretty sure will get us over a 2-digit number. 9 times 12, well, we're already at 90, and then another 18. That's 108. That's not going to work. So that's 7 for sure. That's 4. That's 8. I seem to remember something about evens. Yeah, in column 2. These have to be odd. This has to be even now. Finish box 1. We've got 4 even digits. That's got to be the odd digit. We've actually got 4 even digits in box 7 as well. So that's the 5. That's the 2. This is 6, 8. This is 2, 4. This is, I was going to say 1, 9. I think this is 5. Because if I put a 5 in here, it means I'm either multiplying something to get to 25 or 45. Now, because 5 is also a prime number, the second I put a 5 in any of these at the end, I don't think there's any way for me to be able to multiply anything to get to, 25 or 45. You will absolutely need to repeat the 5. So that's got to be a 5. That's got to be 1 or 9. Let's think about the 9 for a second. 29, that's a prime number. That doesn't work. 49 is only 2 7s. That doesn't work. That's got to be a 1. 41 doesn't work. That's a prime number. That's 21. That's 7 and 3. That's 5 and 9. That's a 1. That's 3 and 9. And that's therefore a 1 and 9. This is going better than I expected, if I'm honest. I was thinking I'm going to be reaching for that calculator any second now. Although, famous last words. I probably shouldn't have said anything. 6, 4, 8. Looking at this cell, that's a 2. This is 4 or 8. Well, this is 4 or 8 as well. Yeah, I'm going to do the easier ones, the things that multiply to 2 digits. I'm not sure I'm up for 3-digit calculations just yet. This is 4, 6, or 8. Yeah, I'm not up for that yet. Have I got anything else that's obvious before I get stuck into trying lots of multiplications? I think the answer to that is no. So 4, 6, and 8 are the options because we don't have 2. It's taken in the column and in the row. So options can't be a 1, can't be a 3, can't be a 5. We've talked about 5 plenty. This can be only a 7. 7 times 4 would be 28. Plausible. 7 times 6 is 42. Not plausible because there is 4 is fine here, but the 2 isn't. So not 6. And then 7 times 8 is 56. And the 6 is not available because there is a 6 there. So that's 7 and 4. That's 28. That's another even digit. There's a 6 in here somewhere. Don't know what it is. This is 1 and 5. That 1 tells me the order. That's 5. That's 1. I'm sorry if you're hearing this. That's just interference from my phone and the speakers. Hopefully moving it away from the microphone and the speakers will just stop that for a moment. 6 or 8. Lots of options here. I mean, so it's not 2. So this is either 4 times 6 is 24. That doesn't work. 4 times 8 is 32. That does work. So that's a possibility. 8 times 6 is 48. That also doesn't work because that's 40. 8 times 6 is 48. Not something that ends in 2, which is what we need in here. So that's 32. That's 4 8s. That's a 6. This 4 is looking up here. That's an 8. That's a 4. That's an 8. That's a 4. I've got 1 and 3 in here. 5s eliminated. That's a 5. 7, 9. Can't tell where. Can't resolve these at the moment, but 7, 9 pair are looking at this 3, 9. That's a 3. That's a 9. I need a 1 in here. And an 8. And another 2, 6. Not helpful. This is 2 or 6, in fact. This is 4. Should pay attention. Right. This can't be 5. We've been through this before. So that's 3, that's 1, that's 2, that's the 5, and that's a 6. That's 8. And I've got a bunch of options in here. 1, 2, 3, 4, 5, 6, 7, 9. Not a 6. Can't resolve anything else, it seems. Actually, the 1 and the 9, that resolves these. Have we got anything else? 7, 9s? Nope. 5, 7. Actually, the 5 gives me the 7, the 9, the 7. This is 1 and 3. This 3 tells me the 3 is down here. 1. I need a 9 with a 6. Not resolved. This 8 gives me the 6 in here. I need a 4 in there. This is 1, 3, 7. Again, I'm fairly sure I can't use a 5. 5 times a multiple, an even digit here would give me a 0. It breaks the puzzle. So that's got to be the 9. This is a 4, 5 pair. This 5 tells me the order. That's the 5. That's the 4. This is an even digit. This is odd. This is 9, 5, 8. 1, 9, 5. This is 3 or 7. Not resolved, it seems. This is at least a 6. 6 or 8. In fact, there's a 9 in here. That's a 6. That's an 8. This is 3 or 7. That's another 3 or 7. In fact, it's resolved because I've got a 3 in the column. That's a 3. That's the 3. That's the 2 or 6. I've got a 2 in the column. That's a 6. I need a 2 in here with a 1. That's a 9. So 4 times 9 times 3, that's 72 times 3. It's clearly going to be 200 something. That's 216. Do I want to check my maths? May as well. 72 times 3, so that's 2 times 6, that's the 6, and then 70 times 3, that's 210. Yep, that's good. 4, 8, 4. I think I've done basically all the maths now, so it's just Sudoku. 6, yep, just these two 6s. This 7 gives me the 9, 7. I am going to do a bit of coloring, just, because all of these are now odds. This is the last even digit, the 8. I need a 5 and 7. That's the 7. And if I've not made any mistakes, that's the 5 in the solution to today's puzzle. It's a phenomenal puzzle, Rocky. I absolutely love this. Can't really ask for a more enjoyable puzzle than something along those lines. I'm just, thinking it through. It is probably what helped me immensely was just coloring everything, thinking about the multiples, realizing the 5 can never be on any of the circles or squares. It can never be on a square. And then spotting that this is just a single digit and therefore easy to break in. With evens, that's quite restricted, and then that's another one. Then just working your way around the grid, basically. Felt fairly straightforward. But I think you just need to sort of be mathematically astute to sort of be attracted, I guess, to the easiest equations that are basically in this puzzle. So thank you so much for the puzzle, RockyRoer. Really looking forward to everybody's comments. Hope you enjoyed today's puzzle and today's video, and I'll see you back for the next one. Bye for now.